Hi, this is Ajay Agarwal. I did my master's in physics from IISER Pune. I studied under Professor Deepak Thar, the winner of Padma Bhushan Award 2023. In this lecture, I'm going to discuss on the topic electrostatics. So, what is electrostatics? Electrostatics deals with the study of forces, fields, and potentials arising due to static charges. In nature, we find two types of charges. The first is positive, which is actually the proton, the fundamental positive charge particle, and negative, electron, another fundamental negative charge particle. Now I will discuss the basic properties of charge. Basic properties of charges. So the first property is additivity of charges. So it states the total charge on a system is algebraic sum of individual charges present on that system. So for example, a system has Q1, Q2 charges. The total charge on that system is algebraic sum of the charges. Now let's understand this by an example. For example, consider an hydrogen atom. Consider a hydrogen atom. So in hydrogen atom, electron revolve around a proton. So in this system, that one charge is this proton having a charge of plus E. The second charge is electron having a charge of minus E. So total charge on this hydrogen atom is Q1 plus Q2 is E minus E equals to 0. So hydrogen atom as a whole is neutral. Now the second property is charge is conserved. It means charge can neither be created nor be destroyed. charge can neither be created nor be destroyed. So just we can't destroy a charge, we just can transfer a charge from one system to another system. The third property is quantization of charge. It states that the charge on a system or on a body is integral multiple of basic unit of charge. The charge on a system or body is always an integral multiple of basic unit of charge. So the equation writes Q equals to NE. N is an integer, where an integer. Now discussing about the SI unit of charge. SI unit of charge. So Coulomb, represented by symbol C, is the SI unit of charge. The value of basic unit of charge in Coulomb is E equals to 1.6 10 raised to minus 19 Coulomb. Now I will discuss a problem. The question is, how many electrons make a total charge of 1 Coulomb. So we have to find the number of electrons that is required to make a total charge of 1 Coulomb. So let the number of electrons be n. Solution. Let the number of electrons be n. So n into basic unit of charge must be equal to 1 Coulomb. So n equals to 1 upon E, and we know that value of E is 1.610 raised to power minus 19 Coulomb. This Coulomb cancel with this Coulomb, so it's just a number. So we have 100 divided by 16 to 10 raised to power 18 electrons. So when you divide 100 by 16, we get 6.25 into 10 raised to power 18 electrons. Now next topic is the Coulomb's law. Coulomb's law. It states that the magnitude of force between two charges is directly proportional to the magnitude of product of their charges and inversely proportional to square of distance between them. So let's try to understand this more deeply. So suppose I have two charges, point charges q1, q2, and the distance between them is r. So the force magnitude is directly proportional to the magnitude of product of their charges and inversely proportional to the square of distance between them. Combining these two equations, we got removing the proportionality sign, we obtain where k is a proportionality constant. K is a proportionality constant whose value is 1/4 pi epsilon naught, where epsilon naught is permittivity of free space. The value of epsilon naught is 8.85 10 raised to power minus 12 Coulomb square per Newton meter square. So if I try to find the value of k from this, it come out to be 9 into 10 raised to power 9 Newton meter square per Coulomb square. These are the important values. One should remember these values. Now I will try to solve a problem on this Coulomb's law. What is the force between two charged spheres having charges 20 microcoulomb and 40 microcoulomb placed 30 centimeter, placed 20 centimeter apart in air. So we have given Q1 to be 20 microcoulomb, Q2 to be 40 microcoulomb, and this R is 20 centimeter. Converting this into meter, we get 0.2 meter. So the force is K Q1 Q2 by R square. This magnitude, we are just concerned about the magnitude of force. So the K is 9 into 10 raised to power 9, and this Q1 is 20, Q2 is 40, and they have microcoulomb 2 times, so we have 10 raised to minus 6 square, and the R is 0.2, so this becomes 0.2 square. Solving, we get 9 into 800, 20 into 40 is 800 into 10 raised to power 9 into 10 raised to power minus 12 divided by 4 into 10 raised to power minus 2 is 4 cancel 200 times. So we have 1800 into 10 raised to power of 9 into 10 raised to power 2 into 10 raised to power minus 12. So this becomes 1800 into 10 raised to power 11 minus 12. So this is 180 Newton. Thanks